Hello there. Okay, welcome to the lecture for Chapter 6. Okay, so now we're going to be looking at discounted cash flow evaluation methods more carefully and more thoroughly than we looked at them previously when we got an introduction to the internal rate of return method. Just to make sure we're all on the same page, in finance, a project is any venture by one person, group, or entity requiring one or more cash outflows and resulting in one or more cash inflows. And investments mean the same thing as projects in finance. And an investor can be any person, group, or entity evaluating a project from their perspective. Okay, so a project is going to be any financially related thing we can think of. Buying a company and launching a product, making a loan, buying a bond, okay? And in general, investors in financial projects, they want to know how much a potential project will add to their wealth, or another way to say that is how much a potential investment is worth to them. In general, for all of our discounted cash flow methods, they give us a great way to understand what the worth of a project is to a particular investor who may be a lender or may be a sponsor. In general, with these methods, we take the approach that if the project's time normalized cash flows are greater than its time normalized outflows, then the project is going to be worth more than zero. It would add to the investor's wealth and it should be pursued. What do I mean by time normalized? Time normalized means putting all of the cash flows in present value terms, okay? Remember, cash is an exponential function of time, so we cannot add together a cash flow for one investor at time t equals 0 to a cash flow she may be getting in 3 years. We have to discount that 3-year out cash flow back to its equivalent for her at time t equals 0. Then we can add it to any other cash flow we have at t equals 0. That's very important, and that's foundational for all of the DCF methods, okay? And in general, if we use these methods, the great thing about these methods is that we can evaluate any project by considering these time normalized, discounted, i.e., discounted cash flows, positive and negative, and we're also going to have to think about the project's riskiness, which we'll measure by the interest rate or discount rate, as well as the individual cash flows. With all of these things in mind, we get the present value of all the cash flows for the project for this player. And then if for that player, the present value of the positive cash flows is greater than the present value of the negative cash flows, then we want to pursue the project, okay? And always, always, always consider all the cash flows for one player at a time. Don't confuse lenders and sponsors. Evaluate one at a time. Okay. So again, we're using our present values of cash flows, and there are two important methods for us to consider in real estate finance that are discounted cash flow methods. The first is the net present value method, and the second is the internal rate of return method, which we've already looked at briefly, okay? And what we're going to do with all of these is where both of these, we're always going to discount all the cash flows back to t equals 0, because that's when we have apples to apples. That's when we can add them up. So discount them individually one at a time, then we can add them up. Okay. All right. So now we've had a little introduction already to the IRR method. Now let's look at the NPV method. The NPV method is the word and the light and the way as far as DCF methods go. It is the best method. IRR, as we've discussed previously, and we'll discuss more today, does not always work for every project, okay? But the NPV method does for any project. So let's get a little pedantic. What do we mean by net present value? Net present value is going to include all of a project's cash flows, including any at t equals 0. So note difference from earlier chapter. Okay, so mathematically, net present value we define like this. It's just the sum of the present value of all the project's cash flows for one participant, including anything we pay or receive at any time, including at t equal 0. Okay, so how are we going to write that in summation notation? We're going to write it just like this. It looks very familiar to what we've seen previously defined as PV. The reason that we have an N here now is because now we're considering all the cash flows, not just the future cash flows, okay? Previously, we were saying I equal 1 to the number of cash flows to signify we were looking at only future cash flows. Now we are looking at every stinking cash flow for a given project, okay? Including any cash flow in or out at t equals 0. Okay, so all the NPV is, it's just an adding up of a project's time normalized cash flows. Great thing about the NPV method, you know we've been waving our hands a little about sign conventions up until now. Once we step into the domain of the NPV method, we're always going to use a correct and proper algebraic sign convention, okay? So the NPV evaluation method says in words, if all the project's time normalized cash flows are greater than 0, we'll make money on the project. If not, we won't. Okay, so that's a very cool thing that we get out of this equation. So the evaluation method that we're going to use with the NPV equation is to just say very simply, we're going to invest in a potential project if its NPV is greater than 0, period. No ifs, ands, or buts. So it gives us a really nice way to evaluate projects, okay? All right, so now we have to think a little bit about what are our cash flows and discount rates for the NPV method. What cash flows do we want to put in? What interest rates do we want to put in, and why? We are going to use always for cash flows project risk-specific expected value cash flows. Here's an example showing what I mean. Let's say we have a project coming along where a sponsor says, in a year, we put some money in now, in a year, we're going to get $10 back, okay? That's what the sponsor claims, all right? We know this sponsor. The sponsor's done about 100 projects, and we've been able to look at them. 95% of the time, what the sponsor claims is true, but 5% of the times, he flames out, he screws up. The projects don't work so well, okay? So when that happens, on average, what investors get is $5 back instead of $10 back. So the project risk-specific cash flow for this project with this sponsor offering it to us is going to be the weighted average cash flow from all 100 projects that we've been able to inspect. So that's going to be 95% probability times that $10 plus 5% probability times the $5 or $9.75. That's our project risk specific expected value cash flow. This is covered in detail in chapters 4 and 5, which are going to be on video for you to look at. Okay. And same thing with discount rates. The discount rate that we always use in the NPV method is what's called the opportunity cost of capital discount rate. And that is the same thing as some people will call the market risk discount rate. Okay, so a little bit like accounting here, more than one name for something. Most people call it opportunity cost of capital. Some people will call it market risk discount rate. So you got to know both terms. What do I mean by as previously learned here? I mean two things. Okay, first is same thing you've learned. This has the same meaning that it did in microecon. Okay, same meaning. Also, this is going to be the same as covered in Ch06a video. Okay, and when we are using now these quantities, we're always going to use the NPV method with our opportunity cost of capital and our project risk specific expected value cash flows. We rewrite the NPV formula as shown here, where we explicitly show opportunity cost of capital and the individual cash flows are assumed to be project risk adjusted. Okay, we have no special designation for them, but we assume that we've done that. Okay. All right, so opportunity cost of capital, it is covered very carefully in the prior chapter, which is on video, and you'll be looking at this week if you haven't looked at it already. But here is a very quick review. For a given project, we define the opportunity cost of capital as the known interest rate we could get for a diversified set of alternative investments or projects, of course, mean the same thing, with similar market or industry risks. Okay, this is pretty much as defined in microeconomics, and it's gone over very carefully in the prior chapters, which you'll have a chance to look at on video. Okay, and our diversified alternative set of investments is called our opportunity cost investment collectively. Okay, so how do we compute this beautiful opportunity cost of capital? As with many things in finance, there is no consensus. There are several methods in common usage which are covered in the prior chapters, which you will be able to look at on video. And also, two of the methods are covered very briefly in this chapter's appendix. You can look at them if you want. I strongly recommend you look at the videos on the prior chapters, which are going to be assigned alongside this lecture. Okay, so ROCC, our opportunity cost of capital, has two important properties. We can always make investments with a return of opportunity cost of capital at any time. How does that work? Well, let's say we're interested in investing in development projects. One thing we could do with our money is we could put our money in the Blue-Green Corporation REIT, Real Estate Investment Trust. They're a publicly traded REIT that develop single and multifamily homes. That would be really nice because that would be a diversified set of projects, single and multifamily development projects, and we could look up the return on equity for the past 10 years or so of Blue-Green and say, hey, if we want to invest in development projects, a diversified way to do that is going to be with Blue-Green. So that could be our opportunity cost of capital. So that's in our back pocket. Then a developer comes to us and says, hey, I have this project. Do you want to invest in it? We would check it out. We would see if it had a positive NPV. And if it didn't, then we'd just say, hey, the money we might have invested with that developer, we're going to throw it into Blue-Green because we know we can earn our opportunity cost of capital with Blue-Green. So that's the way that works, okay? And the second thing we need to know about opportunity cost of capital is that the opportunity cost of capital increases with the risk of our investment mission. Clearly, if our mission is to invest in something like short-term treasuries, the opportunity cost of capital is going to be a lot less than if our mission is to invest in subprime mortgages, okay? So we just want to keep that in mind. Okay, so now back in action with the NPV evaluation formula, and remember, we have our opportunity cost of capital explicitly in here, and we're implicitly remembering that the CFIs are the project risk-adjusted cash flows. And also, of course, now with NPV, this includes every stinking cash flow for the project, including any cash flows at T equals 0, okay? All right, so the NPV method has two important things that we need to know about it. The first one is that the NPV of opportunity cost investments, that would be putting money in the Blue-Green REIT in the last example, are always equal to 0. Okay, so let's do just a little example illustrating this. I think it's obvious by thinking about the Blue-Green example, but let's do another example. So let's say our mission is to invest in very low-risk one-year opportunities, okay? So our opportunity cost of capital is going to be a known interest rate for a diversified set of alternative projects with similar market risks. So what might that be in this case? Well, we could go out to something like bankrate.com and look at the one-year CDs that are on sale there for $100 per CD. And we'd find that the interest rate on those CDs, weighted average interest rate for all 100 of them, is 5%. And so then our opportunity cost of capital would be 5%. That would be on the assumption that instead of looking at a single project, we'd buy this diversified set of CDs, 100 of them, and we'd get weighted average return of 5%. Okay, so now let's take the NPV of these. If we invest in all 100 of these, we're going to get weighted average 5% return. So if we put 100 in, here's our 100 that we're putting in, we would get back 105 in a year, and we'd have to discount that back, so we can add these up together, discount that back by 1.05. So even I can do this math in my head. 105 divided by 1.05 minus 100 is in fact 0.0. Yahoo! Okay, so that works. Second thing we need to know about this is that if we find any mission-fitting investments with NPVs greater than 0, we should make them. Okay, so let's think about our blue-green example again. Our opportunity cost investment is invest in blue-green because they have a diversified set of development projects they're doing all the time. Someone else comes along with a development project and says, hey, I'd like you to invest in my project. We'd get the NPV. If it is greater than 0, that means that that project should make us more on average, if we could keep repeating projects like that, than we would get from blue-green. So we want to go ahead and do it. So that gives us a great rule for applying the NPV formula, which says invest in a potential project if the NPV is greater than 0, and if it's not greater than 0, or if it's equal to 0, don't invest. Equal 0 is included here because if we get an NPV equal 0, using our blue-green example, we should just throw it into the blue-green REIT. It's a lot easier. We can get in and out very easily, no liquidity problems, stuff like that. All right, so let's do an example here. Let's say our investment mission is we buy short-term bonds with strong anti-default guarantees, okay? So that's going to be our mission in life as investors, all right? So we go out to bankrate.com and we find weighted average 1-year CDs. If we got all 100 of them showing on bankrate.com, the weighted average return would be 5%. So that's our opportunity cost of capital. So we want to do better than that if somebody comes along offering us another deal. And here comes someone, happily. Here, distressed seller walks up to us out of the blue and says, hey, I would like to sell you this treasury bond, the contract from the treasury, bond contract, says that whoever holds this bond in a year from now, when it matures, is going to get $110. I want to sell this bond for you for $100. So this is from distressed seller. So we want to know, should we buy the bond? We're going to answer with NPV, right? This is our new great way to suss all this stuff out. All right, so let's go ahead and do that. So we have our NPV evaluation formula up here, and all we need to do is plug in. We know our opportunity cost of capital. We know if we do this deal, we have to pay 100 now. Treasury says we're going to get 110 in a year. we don't have to worry about any risk adjustment here because, as you will learn in the video on Chapter 4, Treasury investments are considered to have a negligible probability of default. So essentially, we treat them as risk-free, although of course we know the Treasury could default. We assume it's not going to. So we can use that cash flow as is, no adjustments. So let's see if we can get the NPV for this. So I'm working off the formula up above. Okay, so I start with my minus 100 and then plus 100 divided by 1 plus 0.05 raised to it's a 1-year deal. And if you work that out, you will find that you get $4.76. That's clearly greater than zero. So we want to buy this bond. We want to do this deal if, in fact, our mission is to buy short-term, very low-risk stuff. This is short-term, very low-risk stuff that's going to make us more money than the weighted average of buying 100 CDs at Bankrate.com. All right, cool. So what are some interpretations of this $4.60? Just like all the lessons we're learning today, there are going to be two important interpretations. Everything's coming in twos today. Number one is the increased wealth concept, okay? This says positive NPV projects increase a firm's wealth by the amount of the NPV. So in this case, if we decide to go with this project, we've just made our firm richer by $4.76. What do we mean by that? Well, richer is measured against making opportunity cost investments, not against doing nothing, okay? And how does this work? Well, if we didn't go ahead with this project, we would have put our $100. We're never going to sit around with it doing nothing. It's always going to go into either our opportunity cost investment or a project that someone is presenting to us that we're considering. If we didn't make the investment, we would have put that $100 into our CDs, plural that should be, earning the weighted average 5%, and we know that has an NPV of 0. Okay, so that's why doing this project, it's the same risk, it is making us richer by $4.76. Pretty cool. Okay, number two, the equivalence concept. Okay, the equivalence concept says that investing in a positive NPV project is completely equivalent to receiving that $4.76 today. Okay, this is really true. Okay, it's a little tricky to think about, so let's go through it. The way you've got to think about it is to consider two choices today. One is we invest $100 in the distressed seller project. Number two is somebody just throws $4.76 in our face. They just literally throw it at us. So we pick it up off the floor, and now what do we have to invest? We have $104.76 to invest in our opportunity cost investment, which is going to be 5% for a year. And what we find is in both cases, at the end of a year, we're going to wind up with 110. Okay, so here's the 100 plus the 476 someone just threw at us. We throw that into our opportunity cost investment. We get $110. On the other hand, same riskiness. We put 100 into the distressed seller project. We get the same thing, okay? So investing in this project is completely equivalent to someone throwing $4.76 in our face today. All right, that's it. Okay, so now let's think about the internal rate of return in the NPV context, okay? the internal rate of return, as we know, we've looked at internal rate of return before. The internal rate of return is what's used very often by lenders to evaluate projects. But in terms of NPV, the internal rate of return is defined to be the interest rate or discount rate that makes the NPV of a project equal to 0, i.e., the IRR is the R that makes this true. NPV equals 0 equal what? Each stinking cash flow for the project, including any at t equals 0, each one individually discounted by the IRR, okay? And this is actually exactly the way we formulated the IRR when we looked at it previously. Remember, we brought the cash flow at t equals 0 over to the right-hand side of the equation, and then everything else was that made the whole equation equal to 0. So this is just formalized, done for us automatically with our NPV formulation of the IRR method. Okay, so this suggests another great way for us to evaluate potential projects. Okay, so first thing is establish, as usual, our opportunity cost of capital and all the project's cash flows. Solve for the IRR using the equation above, and we may need goal seek for this. Okay. And then the really nice qualitative warm fuzzy thing about this is that if the IRR of the project is greater than our opportunity cost of capital return, we should go ahead. If it's less than or equal to, we don't want to go ahead. So the IRR method gives us this really nice sort of qualitative way to intuitive way to immediately understand our projects, okay? So as we know, however, there are problems with the IRR method, okay? We know that whenever we solve for an IRR, we're finding the roots of a polynomial or a real equation. As we know back from high school algebra even, a real number solution might not exist, and sometimes we have multiple roots. We don't know which root is the right root. NPV never has this problem. It's a more robust method, and that's why it always works, okay? And as we've talked about before, this is a typical cash flow diagram for sponsors, right? Which we often call equity, okay? And these are typical cash flow diagrams for lending deals. And the beautiful thing is that the mathematicians have shown us that if you have cash flow diagrams like this, or if you flip either one of these over the x-axis, gives us 4 possibilities here. If you have cash flow diagrams with, for example, 1 negative, all the rest positive, or it could be 1 positive here, all the rest negative, all negative, at the very end positive, etc. A total of 4 of these permutations. The mathematicians have told us that there are roots to the equation we have to solve. If we can find the smallest positive real root, which is not numerically guaranteed, then that is the IRR. So because there are so many lending projects that look like this, okay, most lenders and issuers of bonds are going to use the IRR. And in the bond world, whenever somebody's talking about yield to maturity, all they're talking about is the IRR of the project by the bond. Okay. All right. So let's solve the distressed seller example with the IRR method here. So we know our opportunity cost of capital, we know the cash flows, and I'm going to now use the NPV equation, but set it equal to 0 and plug in my IRR and solve for that. Okay, so through the magic of algebra, it looks like I haven't written down a step for us here, so I'll just write it down for us now. So after a little algebra, the statement to the left becomes 110 over 100 minus 1 equals the IRR, and that's going to be 10%. So that's greater than 10% is in most circles greater than 5%. So buy the bond. So heads up that IRR, when we can use it, should always give you same result, thumbs up or down, as NPV. Okay, so that's a nice thing too. You can check your work when you can use both IRR and NPV. If the NPV says go for it, the IRR should say go for it. Okay. All right. So here's another quick IRR example. Let's say we have the same investment mission and our opportunity cost investment is then therefore going to be by the portfolio of CDs, opportunity cost of capital 5%. Should we buy a US dollar denominated German government bond costing 100 and returning 112 in 2 years? Okay, so first, we decide that this is low enough risk. Okay, U.S. German government, very, very high quality government. They've never defaulted on their bonds. And this is a dollar denominated German government bond. So it's very, very safe. So I'm going to call it safe enough. Okay. So for our NPV equals 0, in this case, we're going to have, once again, minus 100 plus 112 over 1 plus IRR, IRR, okay. And now raised to the 2, this is a 2-year project. This whole thing is equal to 0, so we can solve for it through the magic of algebra. We get 5.8%, and once again, so 5.8% is in most circles greater than 5%. So we want to buy the bond. Cool. Okay. All right. So I'm going to pause here, and the next piece of this I'm going to pick up with in just a second. We'll be using Excel to solve DCF evaluation problem. So we'll pick up with that very shortly.